Okay. Hi. Okay. So I will talk about quotas, but I will talk just specifically about quotas in Apache Kafka and how you could use them to protect performance of your tenants, the tenants which sharing the same Kafka cluster. But first, let me introduce myself. So I'm Anna. I'm an engineer at Confluent, and I work on a cloud-native Kafka team. Our team works on Kafka and specifically on problems related to hosting self-managed Kafka in Confluent Cloud. We are hiring, please join. I really like, we basically, as you can imagine, we do work on problems which is multi-tenancy. We need to make sure that our customers get certain level of performance. I personally really like the subject and I work on it for quite some time in different systems, pretty much all resource management, performance management, and systems and distributed systems. But first, so why we talk about multi-tenancy and why would you care about it? Because Kafka can scale horizontally, right? You can get enough capacity to not only use Kafka as one layer in your application, but also as basically one central system, central event pipeline that connects your different data stores and also serve as the backbone for your stream processing of event-driven applications. So potentially you can have it as one layer serving your whole company. And that's what we talk about when we talk about Kafka being a central nervous system. And that's pretty useful because now, in that case, you can have all your data in one place. It's always easier to access data. And then it's also much less costly to operate less clusters and more. Just think about upgrades you need to think about, or keeping track of all your configs. And also, it's easier to onboard new applications because you don't need to start thinking from oh, what Kafka cluster I need to deploy and so forth. So that's pretty cool, and that comes from that case that you have one shared system. But the fact that you can scale it, it's not enough, right? Because, for example, some applications, you don't want all your teams to see some customer data. Maybe you don't want, for example, some applications access topic partitions. You also need to be careful that you're using the cluster and you expect certain bandwidth, and then you don't want somebody just starting application that can, I guess, just basically maybe misconfigure it, and then they just start sending lots of requests, lots of connections. So you don't want that to happen, and suddenly you don't get your bandwidth. So those are two problems, right? Security and performance isolation, but I'm specifically talking about performance isolation because it's already a pretty complex subject on its own. And when we talk about performance isolation, it's not only that you need to worry about those misconfigured clients. It's even in a normal case, right? Say your application just gets more more usage, right? So it just naturally grows the traffic, and you might just not notice it, but it can take more resources, naturally just start interfering with other applications. And normally many applications, from their point of view, performance is their business value, right? So you do want to be able to transfer a certain amount of data and also have some expectation on latency as well. And so in Kafka, we do have mechanisms to be able to protect performance and keep the limits. So we have produce and consume bandwidth quotas. Those are limits that you set on your application, and Kafka will ensure that you would not be able to get more bandwidth from it. And also you can set limits on CPU, approximation of it, which you can use request quotas. So the concept of limits itself being just limiting your usage, it seems quite simple, but we noticed that many people have lots of questions and some misconceptions. And really questions, I think, comes from the fact that, you set your limit, but you only things that you're actually interested is what actual performance, what I'm going to see, am I going to get at bandwidth or certain latency, for example. So the questions, I think, come from that, right, what do I actually expect once I configure them? So I think that it's easier to think about quotas and what you get if you think about capacity first, right? So it's a kind of same as what you think about when you just deploy single tenant case. So here, let's just get on the same page, like what the Kafka cluster is, right? So Kafka cluster is just a set of machines, right? In which store your topic partitions, and it runs a CPU process, it processes your request, and then it goes through the file system, and it reads and writes to the like one or few disks. So it's just a collection of resources of network, CPU, memory, and disk. But obviously, you don't really want to think it so much detail. So I think it's very kind of simpler and useful to think about that performance capacity of the cluster that you have in terms of if you model, or not model, but think about your broker having certain ability of writing and reading certain bandwidth, right? So like what's a maximum? So like if you say you just deploy your normal single tenant case, right? You still think about capacity. You kind of approximate, okay, my broker can do at most certain write bandwidth, at most certain read bandwidth, and I have some CPU. And that bandwidth, the maximum capacity you have, is defined by, of course, your network, memory, and disk. So I just give like simple example how you can do back of the envelope calculation. For example, right? So in most cases, right, your memory is faster than network and faster than disk, right? So if you think of write capacity, normally, right, you produce to the broker, which writes to disk. So even though, right, usually we would write to memory, but we still have to flush it to disk. So if you think of sustainable performance, sustainable bandwidth you can get is pretty much bounded by your disk. So you can say, right, so like broker can do maximum write based on my disk bandwidth. And then for the reads, normally, if you think of cluster, like say real-time use cases, all your consumers reading from the tail, most likely you read from the memory. So, but of course, network is usually more limiting. It would, of course, depends on like actual real hardware, but just an example. So you say, okay, so my read bandwidth is bounded by network. You can also kind of then go a little bit more detail. Maybe you don't have all the consumers reading from end of the log. Maybe you have some of them kind of behind. So you can also incorporate certain number of cache misses. But I'm just giving an example. Like you can have that kind of quick calculation and think, okay, that's what my brokers can do. And then as a cluster, it has a collection of brokers. So that's your capacity. And that's, you kind of, I think usually would still do this exercise if you plan capacity for just like any workload. And so if you think that way of the broker, now you can, I present it now as a model of this three-dimensional resource space, right? You have whatever maximum write bandwidth your broker can do, maximum read bandwidth, and you still have that CPU we set aside, right? And then that kind of pretty nicely maps into the quotas that you can allocate on Kafka broker. So the quotas framework that we have, quotas are set per broker. So you still think of like per broker capacity, and then of course you add all of them, and that's your total quota would be actually your aggregate of all your brokers. Okay, so now you have the quotas, and we map it to those 3 dimensions. So I kind of said, I think I said the wrong word, reserve. So you actually, when you set quota, when you allocate it, it's not really reserving. You don't just ask, and like, now I have that resource. You don't have the resource. I think it's easier to think about quota in a way that it's a limit. So when you think about being inside that one of the boxes, right, that box related to like some application, right, you think about it is that the broker will make sure that you never cross the boundary. So you allocate the quota, and your quota just makes sure that whatever you do with your load, like whatever request you're sending, they will never exceed the boundary of the 3-dimensional kind of resource something. And that's, one second. Oh, right. And so I think it's important to repeat that it's a quota is a limit, not a reservation. Because why it's important? Because you don't just, if you say, oh, I want some protect my application, it's not you don't just set quota on it and that you think you are done. You actually have to set quotas on everything in the cluster, because just think about it that if you protected, I guess, the potential usage of your application with a quota, if at least one workload will just run unprotected, it can just take over everything. So whatever you are protecting does not make any difference. So and in quotas, I'll tell later, we do have like default. So you can just set default and you add application and you just have at least something. And second, that if you, and here when I guess I will need to more clarify, but if you really want like isolation and you want it to be as if you reserved something, you basically need to make sure that aggregate quota is less or equal to capacity, right? Because obviously if you allocate more, you're allocating not real, or you are kind of considering not existing resource if you exceed it. But in Kafka, right, when they say, when quota is not reservation, it means that that thing, right, like basically having that you need to consider having aggregate quota less than capacity is just kind of a manual admission control in a way. So we don't have, so for example, Kafka, you can allocate as many quotas as you want, and like it just will never give you an error. You just need to think about it like manually, separately from that. And so if you, in that case, when you care about capacity, I think it's also important to note that when I talk about capacity, we need to think about that. Let me actually say a different way. We need to account for application, but that accounting kind of comes separately, because when you reserve quota, the quota reservation and whatever it controls, it only controls client traffic. And what I mean by client, meaning that requests coming from the client, right? But all the replication is still happening. So obviously, if you are saying kind of limiting your write bandwidth, you obviously limit replication that way. But you still think of like, if you think of capacity of a broker, you really have like portion of it. So just an example, if you have replication factor 3, right? So obviously 1/3 of the broker will be doing the actual client traffic, and then there would be getting writes from the other brokers for application. And similarly, one broker getting writes mean that other broker reading, so that also goes into read. So you basically have some, portion of that capacity, and then you can, that's where you kind of think of allocating your quota. What I wanted to say about that part about being less or more than capacity. So normally, I think in real situation, right, when you reserve quota, you don't really reserve them, how to say, you might not actually have that much load, right? So, of course, if you can over-reserve, say like, okay, my total quota is much more than capacity, but if you send very little load, then of course you're not interfering. So you kind of have to think that way. And of course, when you go over capacity, again, it's not a binary thing that you suddenly have no isolation. You'd have isolation, it's just like, it's more likely to interfere. More you go further than capacity, you just higher chance of that, some application will just, make your own performance less. So when so far I was talking, I guess I was using term tenant, but in Kafka, in Apache Kafka terms, tenant is actually, because you call quota entity, and that is defined by a user principal and client ID, or you can just have a user principal. So for example, if you had, as in here, like those two applications, if you wanted to reserve or to allocate different quotas for those different applications, you can, if you have security, you can kind of allocate, have different user principals and allocate for each of them. If you don't have any security, every user is plain text, so that's why you have that option to allocate quota for the like a client ID. And then you also can do it, like you can decide, oh, maybe in that my fraud detection example, one of the consumers group, I wanted to treat it separate, like specially, and have different quota allocation. You can do that too. So you just allocate it for user 1, consumer group 2. And in Kafka, that allocation would be treated completely separately. So in this example, it would mean that pretty much you have quota for user 1 minus that consumer group, then for user 2, and then for user 1 consumer group 2. In docs, we have it's clearly defined, just wanted to mention. And then you can allocate quota through admin client, or you can use Kafka configs, and then you set your quota for producer, consumer bandwidth, and request quota, and you can kind of define your entities, and also you can do kind of default user as well. So, all right, and let's just remember that everything that you do is per broker when you allocate quotas. So just summarize, so bandwidth quotas, right, we have in Kafka produce bandwidth quota, so that's quota which limits the bytes of produced traffic from the that user or user client ID. And then, so broker just, it collects metrics on like how much actual bandwidth you do. So it can easily identify now if you already used up your quota, you don't want to go more. So once broker detects that bandwidth is more than quota, client bandwidth would be throttled, produce bandwidth. And similarly, we have consume quota separately for consume bandwidth. And with consume quota, only consume request, fetch requests from the consumer are throttled. So what does it mean to be throttled from application point of view? So if you have Kafka clients to that on later, so actually real throttling actually happens on client side. So broker still detects, right? Broker still sees, oh, now you're gonna exceed your quota. It will calculate delay for the request, but it doesn't delay it. It would immediately send response, but the response, we have a special field called throttle time MS, and that's a field that would be filled in with actual delay. And then when clients get that response, they would throttle the connection. They will not send next request until that delay is up. But for all the clients, they don't understand that field. So before we actually had an implementation before where quota would delay requests, but that was kind of troublesome. Actually, but sometimes it would give you more problems because, if you delay requests, you can actually time out and you start sending more requests. So it will defeat the purpose of having that quota. So that's why we do delay on client. But for all the clients who don't understand, a broker not for all it always does that. It doesn't not only adds delay to the response, it also will mute the channel. So older client might still send the request, but it will not be processed until the delay. And also because the fact that like you can think, oh, but what if clients send next? But normally clients, right, we have just few connections and they are like closed loop kind of workload. So you don't just suddenly, especially for producer consumer, you don't just suddenly send new requests. Okay, so what we noticed, I don't think I know actually anybody who uses request quota outside of Confluent, but maybe somebody is, okay, not. So, and so normally people set a bandwidth quota and then, and I think maybe sometimes it's kind of the idea of, oh, maybe that's how I already get the bandwidth, right? So the question is, do I get a bandwidth? What bandwidth do I have? So the answer is, one is that you for sure don't get any more bandwidth than the quota because we're gonna throttle you. But the remaining, like what actual performance you get, it will be same answer if you think about the just single tenant case, right? If you have some brokers of certain capacity, right, being able to do certain bandwidth and CPU, you don't always get your performance. You will get your maximum bandwidth if your application is very efficient in batching, right? If you design it in a way that it can get your bandwidth with very few requests, you don't make too many connections, you can get your bandwidth. But it's also, we notice sometimes it's kind of easy to design just have an application, too many clients, each of the client being very low throughput, but then, it just ends up that same bandwidth achieved with like lots of requests, and requests take CPU. So in that case, you just have less. But again, how much less you get bandwidth, it will depend on how much CPU you have. So at least, I guess, next answer to that would be at least set your request quota because you want to limit your CPU as well because then somebody can just easily take over. So the reason I think, I thought here I will talk about request quota, but I think the reason why people don't use request quota, because actually they're pretty hard to not only explain, but also decide how much to set. Because CPU quota is not really CPU. I mean, sorry, request quota. It was done as approximation of CPU, right? And CPU, right? So because Kafka is runs in the user process, you want to be able to limit certain client IDs or users. It's really actually hard. Like, how would you measure CPU? You need some kernel support, right? So we actually don't measure CPU, but we our request quota. It's actually it limits time on I/O and network threads. So it's an I/O network thread utilization. So actually, let me show me this slide, and I will come back. So I draw a little picture just in case. So that's only part of the broker, which does request processing, right? So in broker, right? So you have acceptor thread. It's not in a picture, so they accept connection. But once you have connection, one of the network threads will pick up request, and then it will put it in the request queue. Then one of the I/O or request handler threads will pick it up, process it. It's also would actually, like, for example, like memory access will be part of this. We'll put it back to the response queue in network processor, and then request will be sent back. So that's pretty much like request processing path. And so the time on request handler and network threads are the one which is limited. So not the time in queues, but just the time that those threads are processing. And why at least this is useful, right? So it's kind of reasonable approximation, because there is quite some CPU heavy or overhead things happening on that request path. So the most, I would say, what we think that usually have bigger overhead is encryption, like SSL, TLS. Old clients doing down conversion take quite some CPU, and also request processing. But when I mean about request processing, is more about when you have lots of requests. So once it's set up to be like really high, you know, on CPU. But there are some things that request quota will not prevent. So for example, just somebody making connections, you will not limit them. So you still potentially have some malicious, but at least for like normal clients, will behaving or not, potentially maybe not most efficiently designed, you'll be able to limit your quota. So again, just go back. So first thing to remember is that when you reserve or you allocate request quota, you allocate out of that capacity, which is basically time on network, no, not time. It's a number of I/O threads plus number of network threads multiplied by 100. So by default, we have 8 I/O threads, 3 network threads, so 1100 is your capacity. So that already sounds like, honestly, too complicated. Okay, and then I will come back to what's to allocate. So one is basically everything about what I described about quotas apply, the way you allocate them. The difference between bandwidth and bandwidth quotas is that, you know, producer quotas, they only throttle produce fetch requests, but request quota, once you hit that limit on that usage of threads, all requests get throttled, except I listed some requests which are not. So those are always exempt from throttling, and those requests like leader and ISR, you don't really want to throttle. So like you will have more problems than solutions. So in a question I put in the end, like, what should I set this request quota to? And again, this is actually really hard answer because, right, it's sometimes it's not, there are too many variables, like to say, oh, how much, what you exactly gonna get, right? So, but at least the first advice is that set it to something, at least, and just like say, divide it whatever that capacity is, and then you might tune it. But actually, I mean, I think there are 2 points I want to make. One is that when you think of request quota, don't think about it that way, that, oh, maybe my application uses lots of bandwidth, so maybe I need lots of CPU. It's actually I would say it's pretty unrelated. You need more request quota, or I would say that CPU quota, if your application is not very efficient in using that bandwidth. So less efficient it is, more quota you would need. So usually with very small number, you can just think of like, oh, maybe just how many cores I have divided. So you can set it small, but you might increase it if you think, oh, my application doing too many requests. Or maybe you go and improve application, the way it uses bandwidth, because it's always better that you actually get more out of the whole cluster. So that's pretty much it. So in summary, first thing is that it's important to set all the quotas. Don't have any application without quota, because then everything else just does not really, it can be useful because they just can take over everything. Then when you think about quotas, think about capacity, similar what you think about like planning your cluster, and think of quotas that slice, like three-dimensional slice of what you have. Because when you think about what I'm getting is more like, okay, so if I had that broker of that specific capacity, what would I get from it? And then one thing I didn't mention is latency, right? Because you also like the question like, oh, but what about latency? Would I get it? So in Kafka, we don't have a explicit way to control it, right? But just like, let's think about latency, right? Latency, of course, you will have, it would take network, memory, or disk, right? So those are physical resources you would need to hit. But the bigger part of latency would come from, queuing delays, right? The more load you get on a broker, bigger queues. So, and the worst part when it becomes really, really bad is when, obviously, like if you send more load that broker can sustain, obviously just gonna kind of queue up and so forth. So actually setting a quotas and trying to set the total, or at least that usage is at the capacity, will actually do pretty well. You would be almost like at a kind of single tenant or similar case. And yeah, that's it. Oh, that was pretty fast, but okay, thank you.
Any questions for Anna?
Priorities. Oh, okay. So question is, can we assign priorities? No. Yeah, basically, so in Kafka, we only have quota mechanism. So pretty much in the way that you just assign, you kind of think about it as a share of that cluster, right? So you can, if you need priority, sometimes you can get away, right? Because the share goes, right, it's pretty small window when the quota, right, get applied. So in some way you get your, I would say like you might get that behavior you want by setting quota. Right. Yeah, I guess preempting. Yeah. I guess you can preempt. I think the point maybe I was trying to make, right? So you still, right, if you reserve quotas like in capacity, you would still say like 30% just being like out of whatever bandwidth, you're still gonna get it, right? Although you don't get preempted, it's true. So the thing is in Kafka, things still go to the same queue. So they're still gonna be unqueued in that way. So yeah, there's no way to support preemption if you really need it.
I was just thinking you can just allocate a larger quota to your higher priority client. But yeah. So on that, I was going to ask, is there a monitoring capability available with Control Center or something where we can actually get alerted that you're at 95% quota or something like that? And then
I actually don't know if we have that, but that's actually a good idea. So, but there are metrics obviously in Kafka because the throttle time you see if you get throttled. So, but the Gmax metrics. Yeah, but I don't. As far as we know, I don't think we have that, but
I think
that's good,
even if it's not a real-time alert, right? It'll be good to know which client is periodically hitting the quota over a period of a week, 2 weeks, whatever.
Yeah, that's pretty good. Okay, well, tell if they're not there. Yeah, I think it's actually a good idea. I don't think we have. Yeah. Oh, right. So yeah, if you set it, you basically admin client, right? You have command to set it, you also can get. But actually, good question. So
Can you repeat
we
the
do
question?
add, oh.
Can you repeat it?
Oh, sorry, yes, okay. No, I forgot. Sorry. Oh, right, how do you know? Yeah, for example. So because you set quota, right? So you like use that admin client command or that Kafka config to set quota. How do you like, you need to query Kafka, do I have quota? Currently, we do, so you would query and same, like admin client has a command to read it, and then you will see what your configs are. I forgot the keep name, but I think we just proposed and we got accepted the keep where we have better API, and we not only query that config, but also like saying, oh, given that user and client ID, how much quota they will have. It's just easier like to see, right? Like because the quotas, as we noticed, like they applied kind of from more specific to less specific. So sometimes if you have too much, it's a bit hard to see. So that new keep, I think, will improve life a lot because you see, like you can query, okay, that's quota I get when I. Or as a metric.
When you see quotas, the first thing I almost see a dashboard.
Oh, yeah. So, okay, that's a bit different. So question is like metrics again. Yeah, so there are metrics, GMX metrics if you hit the quota. And as far as I remember, they also they're tagged with a user and client ID. So yeah, you get metrics, but it's like more like I'm throttled or not. So I think it's like reasonably enough. Oh, and actually client, because that throttle time comes back to the field. Yeah, so actually it's also a client metric as well, because clients know, like they receive that information.
Okay, let's thank Anna again. Thank you.